By this video, we discuss the questions from 31 to 60 of 2010. Question number 31. A batsman batted a ball. The variation of the force exerted by the bat on the ball with time t is shown in the graph. The ball bounces back in the opposite direction, and they ask for the speed of the cricket ball just after batting. By the Newton's second law, we know that force is proportional to the rate of change of momentum. By that, we have the equation F equal rate of change of momentum, that is F equal m v minus u divided by t. Rearranging the equation, we have Ft equal m v minus u. Ft, we have to find Ft from the graph. So force and time graph is given. Ft, that impulse force, can be found by the area under the graph. The area under the graph can be found by half multiplied by 0.001 multiplied by 13,500, and that is equal to the change in momentum. Change in momentum is m into v minus u. V minus u in bracket. There u is initial velocity, v is final velocity, and you know that u and v are in opposite directions. In this scenario, when we do the calculation, when we use this in the equation, we have to take both velocities in the same direction. So considering the direction, this mv minus u become mv plus u. Then the equating mv plus u to the area under the graph, we can find v, that is 25. Answer is 2. Question number 32. The question is about moment of inertia about the axis A, B, and C. The moment of inertia is related to the mass and the distance square. The rod consists of particles, and the distance from the axis of rotation to the each particle is very small from A, from the axis A. So then the distance r squared is also small. Then IA must be the smallest. When comparing the answers, two answers have smallest IA, that is 2 and 5. Then we'll find which axis has the largest moment of inertia. When you think of C, from C to the farthest point is large. The distance from C to the farthest point is large. So when you square it, it is very large. Then IC should be the largest. Then answer is 2. Question number 33. A cube of wood is floating in a beaker of water as in the diagram. The beaker begins to move in the downward direction from rest with a constant acceleration. The volume of the cube immersed in water is V, and they asked for the variation of V with time when it is moving downwards. Now the whole system is moving downwards, water is moving downwards, and cube is also moving downwards. Both, they all have the same acceleration. So nothing can be, no change can be happened in the system. So answer must be 1. In other words, if you think by using the equations, the cube has downward force mg, the weight, and upthrust upwards u, and if you put the acceleration is a downwards, then using F equal ma, mg minus u equal ma. M is constant, A is constant, G constant, then U also must be constant. For U constant, V also be constant. So answer 1. Question number 34. Two long parallel wires placed as in the figure. They carry equal currents but in opposite directions. They ask for the variation of the magnetic flux density in y direction along the x-axis. You can mark the left wire as A and the right wire as B. Now, A is carrying current out of the paper, B is carrying current towards the paper. To find the direction of the magnetic field, you can use your right hand. According to the right hand grip rule, you have to point the thumb to the direction of the current, and then the other four fingers shows the direction of the magnetic field. So when you keep your hand on A, pointing thumb upwards, then you can see that the other four fingers can turn anti-clockwise. So the direction of the magnetic flux is anti-clockwise. So left to the A wire, magnetic flux is down. Magnetic flux is to the minus y direction. So you can mark left to the A, the magnetic flux density is to the minus y direction. Near the y-axis, your fingers are pointing to the positive side of the y-axis. So the direction of the magnetic flux is to the plus y side. So you can mark that also. Then we'll go for the B wire. Then B wire is carrying current uh, towards the paper. So you have to point your thumb towards the paper. Then you can see other four fingers can turn in the direction of the clockwise. So right to the B, right hand side of the B, your fingers are pointing downwards, pointing to the minus y direction. So the magnetic flux there is to the minus y direction. When you turn and take your finger near y, then you can see that your four fingers are to the plus y direction. So you can mark near y, both magnetic flux densities are to y side, plus y side, and besides uh, the A and B, left side, the magnetic flux is minus y, and for B, right side, magnetic flux is positive y side, minus y side. Then, so you have to choose the best answer which shows this. So at the middle, it should have a value. And also, I have to say that near the wires, magnetic flux density is more. Near the wires, magnetic flux density is more. So there are three graphs, 2, 3, 4 are having that shape. It has a value, and near the AB wires, the magnetic flux density is more. Then away from the wires, magnetic flux density must be downwards, minus y direction. So that the right answer is then 2. Question number 35. It is about the sensitivity of a potentiometer. Now think of a potentiometer. Potentiometer has a potentiometer wire. and a cell is connected across the potentiometer wire. The sensitivity of a potentiometer depends on the potential drop across the potentiometer wire per unit length. Potentiometer is more sensitive when the potential drop across the potentiometer wire is small. The question is how the sensitivity of a potentiometer can be increased. We'll look at the answers. First one, increasing the EMF of the cell connected across the wire. By increasing the EMF of the cell, the potential drop across the potentiometer wire will also increase. So, the sensitivity will decrease. The second answer is reducing the resistivity of the wire. Even the resistivity of the wire is reduced, the EMF of the cell is same. So there will be no effect on the potential drop of the potentiometer wire if the resistivity is changed. Answer 3, connecting a resistance in series with the wire. When the resistance is connected in series with the wire, there will be a potential drop across the resistor. So the effective potential drop across the potentiometer wire will be low. Then the sensitivity is high. So the correct answer is 3. So it is not necessary to explain 4 and 5. We got the answer at 3. Question number 36. Two transformers A and B is shown in the figure. A transformer. The primary coil of the A transformer has N1 turns and voltage there is 33,000, and the secondary coil of the A transformer has N2 turns, and B transformer, primary coil of the B transformer has N3 turns and that of secondary coil is N4, and the voltage at the secondary coil is 230 volt. Now for a transformer, we know that V1 over V2 equal N1 over N2, and we use that equation for the transformer A. Then we can write 33,000 divided by V equal N1 over N2. And for the B transformer, we can write V over 230 equal N3 over N4. We can multiply these equations. Then left hand side, you get 33,000 divided by V multiplied by V over 230 equal N1 over N2 multiplied by N3 over N4. Then by solving this, you can get the answer. The answer is 3. Question number 37. A fish in a lake releases an air bubble. This air bubble comes up and releases air to the atmosphere. Atmospheric pressure is given, density of water is given. The question is to find the depth of the position of the fish. Now here, and also they say neglect the effects of surface tension. So don't worry about the surface tension, only concentrate only on the given volume and pressure. Even the temperature is also constant, so no change in the temperature. So you can use Boyle's law. Boyle's law is PV equal K. PV is constant. P pressure, V volume, P into V is constant. So you use PV, P1 V1 equal P2 V2 to the two occasions of the air bubble. Initially P1 is atmospheric pressure. We say it's P. P plus H rho G. And V1 is given. P2 is atmospheric pressure. V2 is given. So use the relationship P1 V1 equal P2 V2. Then you have P plus H rho G into V1 equal P V2. All the data is given, so you can find H. H is the depth of the position of the fish. So the answer is 1. Question number 38. Air is rapidly pumped into a tire by a bicycle pump. Which of the following is true for air inside the pump during the pumping process? Now here it says air is rapidly pumped. When the air is rapidly pumped, there will be no exchange of heat through the system. So think of the first law of thermodynamics, that is delta Q equal delta U plus delta W. This process happen rapidly, so delta Q is 0. Then you have delta U plus delta W equals 0. Now think of the air inside the tire. The air is compressing. That is, internal energy of the air increases. So we can take delta U as positive. Now you have delta U plus delta W is 0. Delta U positive, then obviously delta W must be negative. The answer is 1. Question number 39. 2 kilogram of water is heated by an electric kettle. They ask for the efficiency of the kettle. The efficiency is given by useful energy output divided by the input energy. The useful energy output is the heat energy absorbed by the water. So that is given by ms theta. M is given, S is given 4200, theta is the change in temperature, 100 minus 28, which is equal to 72. And the heat supplied by the kettle is zero point 0.2 kilowatt hour. You have to convert that to SI unit, that is to joule. In joule, it is 0.2 multiplied by 10 to the power 3 multiplied by 3600. That is kilowatt hour to joule. Kilowatt to watt by multiplying 10 to the power 3 and hour to seconds by multiplying 3600. So your ratio is ms theta divided by this energy supplied by the kettle. That is 2 into 4200 into 72 divided by 0.2 multiplied by 10 to the power 3 multiplied by 3600, and efficiency is given by given as a percentage. So again multiply the whole thing by 100. So your answer will be 84. Answer 5. Question number 40. The variation of temperature theta with time t for two liquids P and Q of equal masses heated in identical manner are shown in the figure. Let's look at the statements. When you look at the statements, you can see they are pointing out some thermometric properties of P and Q. When you look at the graph, you can see that P liquid uh, rises its temperature very quickly, and Q takes a long time to reach that temperature. So this implies that specific heat capacity of P is smaller than that of Q. Now we consider the given statements. A. Liquid Q is better thermometric liquid than P to measure temperature variations in small quantities of liquids. Liquid Q. The specific heat capacity of liquid Q is more. So, liquid Q needs more energy, more heat to show a temperature difference. Now, for small quantities of liquids have a small amount of energy. So, liquid Q is not good as a better thermometric liquid to measure temperature variations in small quantities of liquids. So, A is wrong. B. Liquid Q is more suitable than P to construct a constant temperature liquid bath. Here, the liquid bath has to be maintained at a constant temperature. Now, if you use liquid Q, the specific heat capacity of liquid Q is more than uh, P. The specific heat capacity is more for liquid Q. Then it needs more heat to show a temperature difference. Unless the heat transfer to the liquid Q or from the liquid Q is large, it doesn't show a temperature difference. So liquid Q is better than P to construct a constant temperature liquid bath. So B is right. C. Liquid Q is better than liquid P for heating air in an enclosed room by sending through a spiral pipe as shown. Now think liquid Q is going through the spiral. Liquid Q, the specific heat capacity of liquid Q is more. So liquid Q has more energy, more heat energy to transfer to the room. So liquid Q is better than liquid P. C is also right. The answer is 4. Question number 41. The diagram shows a resistor network and they are asking for the combined resistance across A and B. When you look at the diagram, it is very clear that you can see 5 sets of parallel resistors. So you can find the combined resistance of each set. So that is R by 2. So you can draw another circuit diagram by putting R by 2 for each parallel set of resistors. Now look at your simplified circuit. So at the extreme right, there you have R by 2, R and R by 2 in series. So get the combined resistance of that which is equal to R by 2 plus R by 2. And there you get 2R. And that 2R and the middle branch R by 2 are in parallel. 2R and R by 2 are in parallel. So get the combined resistance of those two. So taking the reciprocals, that is 1 over 2R plus 1 over R by 2, which is equal to 2R over 5. And you can see that 2R over 5 is in series with R by 2 and R by 2. So R by 2 and 2R over 5 and R by 2 are in series. So get the combined resistance of those 3 resistors in series, which is equal to 7R over 5. And that 7R over 5 is in parallel with R. So get the combined resistance by taking the reciprocals. You get the combined resistance as 7R over 12. The answer is 3. Question number 42. The variation of a magnetic flux through a coil with time is shown in the graph, and they are asking for the corresponding induced EMF and time graph. Now look at the magnetic flux and time graph. So until a certain time, the magnetic flux is positive and it is constant. And after a certain time, the magnetic flux, the sign of the magnetic flux is opposite, is negative. So that means the direction of the magnetic flux has been changed. There will be electromagnetic force induced only when there is a change in the magnetic flux. So there is only one instant where the magnetic flux changes. So it shows by the figure 5. Question number 42. The graph shows the variation of magnetic flux through a coil with time. And they are asking for a corresponding induced EMF and time graph. When you look at the magnetic flux time graph, you can see until a certain time, magnetic flux is constant and it is positive. And after that time, magnetic flux is negative and constant. So that means direction of the magnetic flux has been changed. So that had happened only at a certain time. So only at that time there will be the induced EMF is generated. So the induced EMF is generated only at a certain time. So the answer is 5. Question number 43. They ask for the effective resistances seen by the voltage source V across AC and BD. When you look at the circuit diagram, you can understand that this circuit is equivalent to a Wheatstone bridge. So the potential at B is equal to potential at D. So there is no potential difference between B and D. So there will be no current through BD. To find the combined resistance across AC, you can ignore the resistance across BD. Then you have two R's in series, two R's in series, and that series resistors are in parallel. So find the combined resistance of those four resistors. That is R plus R, 2R, R plus R, 2R, 2R, 2R are in parallel. So the combined resistance is R. So the resistance across AC is R. And you have to find the resistance across BD. Actually, it has a R resistance, but they ask the resistance across BD seen by the voltage source. Now you know there is no current through BD, so that means there must be a very large resistance, that is infinity. Infinitive resistance is seen by the voltage source across BD. The answer is 5. Question number 44. A circuit diagram is given. It has a silicon diode D and a variable voltage supply V. When the voltage increases, the current in the circuit also increases. But until the diode gets its threshold frequency, that is 0.7 volt, approximately 1 volt, the current through the diode is negligible. So the current provided by the source will pass through the 100 ohm resistor, obeying Ohm's law. When the diode have the threshold frequency equal to 1 volt across the diode will become forward bias, and the current passes through the diode will increase rapidly. So that means uh, when the voltage increases, the current I increases rapidly after 1 volt. Answer is 2. Question number 45. A small sphere falls through two liquid columns. The viscosities of the liquids are eta 1 and eta 2, and the terminal velocities of the sphere in the liquids are V1 and V2. When a sphere is falling down through a liquid, there will be a viscous force acting opposite to the direction of its motion. So that force is given by 6 pi eta AV. Let's see what are the forces acting on the sphere when it is falling down. mg downwards, upthrust U upwards, viscous force F upwards. Viscous force F is given by 6 pi eta AV. And in this question it says that the sphere is falling down with its terminal velocity. When it's falling down its terminal velocity, there will be no acceleration. So upward forces are equal to the downward force. Downward force is mg, upward forces are u and 6 pi eta AV. So we can write mg equal u plus 6 pi eta AV. And we subject u there, u equal mg minus 6 pi eta AV. For the first liquid, we can write U1 equal mg minus 6 pi eta AV1. Similarly, U2 equal mg minus 6 pi eta 2 AV2. When you look at the diagram, you can see that the first liquid is floating on the second liquid. That is, the density of the first liquid is smaller than the density of the second liquid. So the upthrust given by the first liquid is smaller than the upthrust by the second liquid. Now you can write U1 is smaller than U2. You can use the symbol to represent the smaller than. U1 is smaller than U2. So substitute U1 is mg minus 6 pi eta 1 AV1 is smaller than mg minus 6 pi eta 2 AV2. mg cancel from both sides. Then you have minus 6 pi eta 1 AV1 smaller than minus 6 pi eta 2 AV2. By interchanging the two terms, you get the answer. The answer is 2. Question number 46. A and B are two conducting spheres. Their radius are r and r by 2. Each is having a charge of plus q. And the centers of the spheres are separated by a distance simple d. And the electric potential at the point P is V naught. And they ask for the potential at P when the two spheres are connected using a thin metal wire. Electric potential is given by Q over 4 pi epsilon naught R. R is the distance between the center of the object which is having the charge and to that point. So here we can write the electric potential at P, Vp equal Q over 4 pi epsilon naught d by 2. Distance is d by 2. By simplifying, we get the electric potential at P equal Q over 2 pi epsilon naught d. Then the total potential at P due to the two charges equal 2 times of Q over 2 pi epsilon naught d. By simplifying it, we get the electric potential at P equal Q over pi epsilon naught d. And you know that each each charge is plus Q. So the total charge is 2Q plus 2Q. After connecting the spheres by a thin wire, what will happen? The charges will move from one sphere to the other until each sphere will get the same potential. Okay, now we think the charge remaining in the sphere A is QA, and then the charge B has 2Q minus QA. Now we write the new potential at P. Due to A, the potential at P is QA over 4 pi epsilon naught D by 2. And the potential at P due to B is 2Q minus QA divided by 4 pi epsilon naught D by 2. And after simplifying, you get the total potential at P is Q over pi epsilon naught D, which is similar to the previous potential. So the new potential is also V naught. Answer is 4. Question number 47. A particle having an electric charge is traveling along a circular path under the influence of a uniform magnetic field. And they have given three statements. Out of three, they ask for the correct statements. Statement A, direction of the velocity of the particle is always perpendicular to the direction of the magnetic field. When the direction of the velocity and the direction of the magnetic field are perpendicular, the magnetic force is also perpendicular to both velocity and the magnetic field. And this force provides the centripetal force to the charge to move it in a circular path. To maintain its circular path, that force must always uh, towards the center of the circle, and that so that the direction of the velocity and the direction of the magnetic field must always be perpendicular to each other. So A is correct. Statement B, time required for the particle to make one revolution is independent of the radius of the circular path. To consider that, we write the equation for the magnetic force and the centripetal force. Magnetic force is equal to the centripetal force. Magnetic force is BQV, centripetal force is mv squared over r. BQV equal mv squared over r. So from that we get BQ equal mv over r. And we know that V is equal to R omega. So substitute R omega in V. BQ equal M R omega over R. Then we get BQ equal M omega. We know that omega is 2 pi over T. By substituting 2 pi over T in omega, you can find T equal 2 pi M over BQ. So this shows that T is not dependent on R. It is independent on R. So B statement is right. Statement C, speed of the particle is directly proportional to its mass over charge ratio. We'll consider the equation again. BQV equal mv squared over r. Then we have V equal BQ r over m. And from that, we can get V is proportional to Q over M. It is not M over Q, it is Q over M. So C is wrong. The answer is 3. Only A and B are true. Question number 48. P, Q, R and S, four parallel conducting plates. Each area is capital A, and P and S plates are fixed. Q and R are connected by a rigid conductor. which could be moved up and down together. They ask for the equivalent capacitance of the system. The capacitance of a capacitor C is given by the equation epsilon naught A over D. When you look at the diagram, you can see two capacitors are connected in series. The first capacitor is made up of PQ parallel plates, and the separation between P and Q is X. And the other capacitor is made up of RS parallel plates, and that distance between R and S is A minus B plus X. So let's write the equations for the capacitance of each capacitor. For the first one, C1 equal epsilon naught A over X. C2 equal epsilon naught A divided by A minus B plus X. To find the total capacitance of the system, we have to take the reciprocals since they are in series. So 1 over C equal 1 over C1 plus 1 over C2. Then you can substitute the equations. 1 over C equal 1 over C1 is X over epsilon naught A plus 1 over C2 is A minus B plus X divided by epsilon naught A. So you get A minus B divided by epsilon naught A as 1 over C. Then C is epsilon naught A divided by A minus B. The answer is 5. Question number 49. A free particle with kinetic energy K and de Broglie wavelength lambda enters a certain region and its potential energy become V. They ask for the particle's new de Broglie wavelength. We know that de Broglie wavelength lambda is given by h over momentum of the particle. H is Planck constant. P is equal to mass into velocity. Momentum is mass into velocity. So lambda is h over mv. H and m are constant, so we can write lambda is proportional to 1 over v, because we are considering two instances, and it is easy to take only lambda and v relationship. Lambda is proportional to 1 over v. And kinetic energy K is half mv squared. So we can write K equal half mv squared. With that, we can write V is equal to square root of 2K over m. And then for the new region, the particle's kinetic energy becomes K minus V, because V potential energy, before it had K kinetic energy, so new kinetic energy is K minus V. Then we can write the new velocity of the particle V dash equal, by looking at the previous equation, we can write V dash equal square root of 2 kinetic energy is K minus V divided by M. So that is square root of 2 K minus V divided by M. So now we know lambda is proportional to 1 over V. So for the first one, we can write lambda 1 is proportional to 1 over V is square root of M over 2K. Then lambda 2 is proportional to 1 over V2, which is 1 over V2 is M over square root of M over 2K minus V. So we divide the second one by first one. You get lambda 2 over lambda 1 equal K over K minus V. So lambda 2 equal lambda into K square root of K divided by K minus V. The answer is 2. Question number 50. Two empty boxes, volumes are given, filled with air at room temperature. Room temperature is 30 degrees Celsius. They are sealed and stored in a refrigerator. A packet of silica gel has been inserted into the large box just before sealing it. And later it was found that the relative humidity of air inside the small box reached 100% at 15 degrees Celsius. So this implies that even for the large box, it will reach its relative humidity 100% at 15 degrees Celsius if there is no silica gel inside it. You know that silica gel absorbs water, and because of that, the absolute humidity in the large box is low. So that is why to reach the relative humidity 100%, it should cool down to 5 degrees Celsius. The absolute humidities of air at the dew points, 5 degrees Celsius and 15 degrees Celsius are given. They ask for the amount of water vapor absorbed by the gel. At 15 degrees Celsius, the absolute humidity is 12.7 gram per cubic meter. When it cool down to 5 degrees Celsius, its absolute humidity has been dropped to 6.8 gram per cubic meter. So that means the difference between those two values, which is equal to 5.9 gram per cubic meter, has been absorbed by the silica gel. So per cubic meter, it has absorbed 5.9 grams. So the large box, the volume of the large box is 0.3 cubic meters. Then for 0.3 cubic meters, how many grams of water vapor has been absorbed? That is 5.9 multiplied by 0.3, 1.77 gram. Answer is 1. Question number 51. Two thin, smooth strips of aluminium pasted on a flat, smooth, horizontal wooden surface. Strips are connected to a battery. A uniform upward magnetic field is set up perpendicular to the surface. A steel rod is placed on the two aluminium strips. They ask for the variation of the velocity of the rod with distance along the x-axis. When you look at the diagram, you can see the magnetic field is upward and the current passing through the rod is to your side. To find the force exert on the rod, you can use Fleming's left hand rule. You can set your three fingers perpendicular to each other, that is thumb, the first finger and the middle finger. The thumb gives the direction of the force and the second finger gives the direction of the magnetic field, and the middle finger the current. So you point your middle finger to the current direction and the first finger to the magnetic field direction, and the thumb will give the direction of the force. So when you place your fingers properly, you can find that the force is to the left side. Force on the rod is to the left side, that is to the minus x direction. So velocity is also to the minus x direction. So out of the 5 answers, you have only 2 graphs showing the velocity in the minus x direction, to the minus x direction, that is 2 and 4. Out of those 2 answers, you have to select the right answer, and you know that it when it passes the magnetic field, there are no forces acting on the rod. So the rod will continue its motion with a constant velocity. The answer is 2. Question number 52. An immersion heater is placed in a metal container. It has water in it, and they say it was found that although the heater is kept switched on for a long time, the temperature of water rises only up to 90 degrees Celsius. They ask what would be the temperature of water 10 seconds after turning off the heater. The heat is supplied to the system. So the temperature of the water and the container rises. At the same time, some amount of heat is released to the surrounding. Anyhow, the temperature of the water rises only up to 90 degrees Celsius. After that, there is no increase in temperature. So that means the uh, heat provided to the system is being released to the surrounding at the same rate. That is, the rate of heat releasing from water and the container is equal to 110 watt. Now, when the switch is off, the system will cool down. So, they will release energy to the surrounding. The question is to find the temperature after 10 seconds while it's cooling. The rate at which the water release heat to the surrounding plus the rate at which the container released heat to the surrounding is equal to 110. So the rate of heat loss by the water is given by ms delta theta over T plus rate of heat loss to the surrounding by the container is C delta theta over T is equal to 110. So that is M1 is 4200 into delta theta divide by 10 plus 200 into delta theta divide by 10 equal 110. So you get delta theta as 0.25. And before it was 90 degrees Celsius, the temperature drop is 0.25 degrees Celsius, and the new temperature is 90 minus 0.25, 89.75. The answer 5. Question number 53. An artillery gun is positioned on a horizontal ground and a shell is fired from it. The shell would land at a target which is located at a distance 2000 meters from the position of the gun. Accidentally, the shell explodes into two pieces, A and B, at a certain point of its trajectory. The mass A is twice that of B, and both pieces land at the same moment. They all traveled in the same vertical plane. They have given the position of the landing point of A, and they are asking for the landing point of B from the gun. This question is about the center of gravity of an object. You know, if the shell traveled without any explosion, it will meet the target. So that means it would land 2000 meters away from the gun. You can draw a diagram for that. If there was no explosion, the shell would go in a parabolic path and land 2000 meters away from the gun. Then after explosion, A, the heavy mass, falls at a distance 1800 meters from the gun. You can mark the A's path in your sketch. A's mass is twice of B's mass. So B's speed must be greater than A's speed. So B will go further away from A. So you can mark B's path also in your diagram. Now the important thing you have to consider here is the center of gravity of the shell. Even though it is separated to A and B, the center of gravity would follow the same path as if it was not exploded. So, center of gravity is 2000 meters from the gun. I hope you have drawn the diagram. In your diagram, you can clearly see that the position of the center of gravity and position of A and position of B. And in that diagram, you can see that A is 200 meters to the left from the center of gravity. And now we want to find the distance from the center of gravity to B. Before we said B's velocity is twice of A's velocity. So B's position should be 400 meters from the center of gravity. So the total distance from the gun to B is 2400. The answer 3. Question number 54. A 10 centimeter long pencil is placed along the optical axis of a convex lens. And they say that the image length also 10 centimeter. And they are asking for the focal length of the lens. This question is about the reversibility of light rays. You can draw a sketch of a ray diagram to understand this principle. Keep a point object at a u distance from the lens. You will get a image on the other side of the lens at a v distance. When you place the point object at v distance from the lens, then you get the image on the other side of the lens at a u distance. Compare the displacement of the object and the displacement of the image. Both are same. So the same principle is applied here in this question. The point of the pencil is 20 centimeters from the lens. Now the image will form on the other side of the lens at 30 centimeters from the lens. The other side of the pencil is at 30 centimeters from the lens, and the image of that end would be 20 centimeters from the lens on the other side. So when U is 20 centimeter, V is 30 centimeter. When U is 30 centimeter, V is 20 centimeter. You can use the lens equation to one of the images. 1 over V minus 1 over U equal 1 over F. So if you take U as 20, then V is 30. So apply the values in the equation and you get F equal minus 12. So answer is 4. Question number 55. A wheel is shown in the figure. It is made up of 3 bimetal strips, and these strips are attached to the axis using radial metal parts. This setup can oscillate about an axis perpendicular to the plane of the wheel uh, passing through the center. The period of oscillation of the wheel remains same, unchanged, even if the surrounding temperature is changed. And they have given 3 statements. A, the moment of inertia of the wheel should not change with the temperature. If the moment of inertia changed, then the period of oscillation also will change. And the period of oscillation must remain same. So moment of inertia must not change. So it should not change with the temperature. A is right. Statement B, the shape of the wheel should not change with temperature. Now consider if the temperature increases, the length of the radial metal parts also will increase. Then the moment of inertia will increase. Then it will affect the period of oscillation. But the period of oscillation must remain same. So the shape has to be changed to maintain the same moment of inertia. So the shape of the wheel should not change with temperature is wrong. B is wrong. Statement C, the linear expansivity of metal P should be greater than that of Q. For a moment, we think that the linear expansivity of Q is greater. Now, what will happen if the linear expansivity of Q is greater than P? The linear expansion of Q will be greater than P. It helps the strips to bend inwards and maintain the same moment of inertia. So then it can maintain the period of oscillation same. So C is wrong. Expansivity of Q should be greater than P. Here it is given expansivity of P is greater than Q, which is wrong. C is wrong. So only one A is true. Answer is 1. 3 masses of hot water at different temperatures added to 3 identical containers. Each container has some water of mass m, and finally they achieve theta naught temperature. The containers are allowed to cool. The cooling curves for the 3 containers are given in the diagram. They are asking about the rate of loss of heat from each container. Here it is given the rate of loss of heat from each container is same. So that is rate of loss of heat, that is delta Q over delta T is same. So the rate of heat lost by water and by the container can be written as Ms delta theta over delta T for water, and C delta theta over delta T for the container. C is the heat capacity of the container, and S is the specific heat capacity of water. So we can equate delta Q over delta T with Ms delta theta over delta T plus C delta theta over delta T. Now look at the cooling curves given in the diagram. Uh, Cooling curve for M3 mass. It shows that the gradient is greater than the other two. Gradient greater is delta theta over delta T is greater. That is, it cools very fast. If something cools very fast, we can assume that the mass of it is small. So M3 must be the smallest. There are two answers showing M3 is the smallest. That is 3 and 4. Now we have to think of the temperatures. Rate of cooling is greater for M3. Rate of cooling is delta theta over delta T. Delta theta over delta T is greater for M3. Delta theta is the change in temperature. Now we think the last temperature is theta naught, and before it was theta 3, and the temperature difference is large, means theta 3 must be large. The answer is 3. Number 57, a monochromatic ray of light is incident on a transparent plastic sphere as shown in the diagram. They are asking for the refractive index of the plastic. We mark the point of incidence as A and the point of emergence as B, and the other side of the diameter as C. Then the angle of incidence is I, angle of refraction is simple R. And with the knowledge of geometry, you can mark ABO is also equal to R and AOC is equal to I. So when taking the angles inside the circle, you can write simple I equal simple R plus simple R. I equal to R. Then refractive index N equals sin I over sin R. And they are saying uh, sin theta is approximately equal to theta for small angles. So for sin I, we just write I. Sin R, we write R. So I over R. I is 2R. So refractive index is 2R over R, which is equal to 2. The answer is 4. Question number 58. A source of sound is located at a point above the Earth's surface. In the daytime, the air temperature decreases gradually when moving upwards from the Earth's surface. They are asking for the best figure which represents the wave fronts of the sound emitted from the source are propagated. In the daytime, the air temperature near the Earth's surface is more than the air temperature above the Earth's surface. And also, the speed of sound is directly proportional to the square root of temperature. When the temperature increases, speed of sound increases. By comparing the V equal F lambda, when V increases, lambda also increases. When V decreases, lambda also decreases. And near the Earth, V is more, so lambda is more. The separation between the wave fronts is more near the Earth. Above the surface of the Earth, it is opposite to what we explained here. V is small and lambda small, and the separation between the wave fronts also small. The answer is 3. Question number 59. Two cars are moving as shown in the figure. Initially, the car B is moving faster than A, and suddenly B slows down and stops. A continues to move at the same speed, and then A passes B. Then they are asking for the graph that best represents the variation of frequency of sound heard by the driver of B with time t. Both the cars are moving in the same direction. After some time, B stopped, but A continues its motion towards B. That is, B is stationary, A is moving towards B. Observer is stationary and source of sound is moving towards the stationary observer. When the source of sound is moving towards the stationary observer, the frequency of sound heard by the stationary observer is more than the actual frequency. So the frequency heard by B is greater than F naught. 2 graphs out of 5 shows this change, that is 2 and 5. After that moment, A continues to move at the same speed passing B. So now the observer is stationary. Source of sound is moving away from the stationary observer. In this case, the frequency of sound heard by B should be lower than the actual frequency F naught. So when comparing 2 and 5, 5 shows that change. Even without considering the first part of the motion, we could get the correct answer. Answer is 5. Initially, a metal rod is at 0 degree Celsius. Then two ends of the metal rod were kept in different temperatures, 100 degrees Celsius and 37 degrees Celsius as shown in the figure. Asking for the rate of flow of heat along the rod with distance x. Now the temperatures at the ends of the rod are 100 degrees Celsius and 37 degrees Celsius. And initially the temperature of the rod was 0 degrees Celsius. Now consider the bottom end of the rod. The temperature difference is there between the rod and the water. So the heat will flow from the bottom end towards the top end. When you consider the top end of the rod, the person's hand has a temperature of 37 degrees Celsius, and the rod's temperature is below 37 degrees Celsius. So the heat will pass from hand to the rod downwards. So there will be values for rate of flow of heat from both ends. So when you consider that point, you can select two answers from the given 5 answers. They are 2 and 5. When you think of the answer 2, the rate of flow of heat has a linear relationship with x. But in the diagram and in the explanation of the question, they don't say that this system is insulated. So there will be heat loss to the surrounding. So the relationship cannot be linear. Then answer is 5. Thank you. You can subscribe the channel to get more videos on paper discussions.